Welcome back, ladies and gentlemen. So, today we're going to be talking about congruence and triangles. Now, we spent yesterday discussing what a triangle is and how to create one with three sides and three angles that add up to 180. Boom, there it is. But congruence is, again, when we're talking about things that are the same size and shape. Okay. So, again, the first key vocab we have here is this. You will also see this symbol being dropped a lot. That is for congruent. Okay. Now, when two figures are congruent, the corresponding angles are the angles that are in a corresponding position and are congruent. Okay, basically you're trying to match things up for corresponding angles. We'll talk about that in a moment. And when two figures are congruent, the corresponding sides are the sides that are in corresponding positions that are congruent. Don't you just love when they use the actual word that you're trying to define in the definition? Anyway. So write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. All right, let's take a look at the angles. I have a triangle ABC. I have a triangle RPQ. This is 1 dash. That's going to be congruent to 1 dash. So I can say that angle A is congruent to angle R. 1, 1. Then I can say angle B is congruent to angle P. You're basically playing a big game of matching. That's all you're doing here. All right. Obviously, that leaves me with C and Q. All right, cool. As far as sides go, one tick mark matches up with one tick mark. So I can say that side AB is congruent to side PR. I can say that side AC is congruent to side QR. And lastly, I can say that side BC is congruent to side QP. Thank you for catching me. Alright, the big thing then is the congruence statement. I want to say that triangle ABC is congruent to this triangle. You have to match it up appropriately. A, B, C. One curve, two curves, three curves. One curves, two curves, three curves. R, P, Q. It does not sound like much. It is a huge deal. Okay? Because the congruence statement tells me which parts work, or which parts are the same. We're going to use that in example 2. In the diagram, polygon DEFG is congruent to KLMN. This thing is everything. I don't have to even look at the pictures over here. I'm able to tell which sides and which angles are congruent to one another. For example, angle D is going to be congruent to angle K. First. E to L, F to M, G to N. So here, I'm going to take a look at solving for X. Here's X. X is on the outside, so it's side MN. Come over here. MN is going to be congruent to FG. What's FG over here? 12. So I'm able to say 5x plus 2 equals 12, and I'm able to solve this equation. I knew that because of my congruence statement. Subtract 2, 5x equals 10, x equals 2. Cool. Y. Now I'm over here. There's my Y. It's an angle L. I'm on the interior. So back over here, angle L is the second one. The second one over here is angle E. Angle E is 111 degrees. So 5y plus 6 equals 111. Now I can subtract 6 over. 5y equals 105. Divide. Y equals 21. Okay, all is well. Okay, so looking good. A few more theorems for us. This one's important, but it's kind of a common sense theorem. You don't really necessarily need to memorize this one. Theorem 4.3, third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles must be congruent. If A is congruent to D, B to E, then I know that C needs to be congruent to F. Just because if think about it, the three angles got to 180, you know it'll work out. Okay? So using the third angles theorem, find the value of X using the given diagram. Here's the 30 degrees, 110. This is for the 1 arc, 2 arc. How can I find this third angle? Well, alright. 30 plus 110 equals 140. I know that 180 minus 140 can give me 40. Alright, cool. Over here, one arc is 30. I'm mashing them up. Two arcs, 110. Oh, we already did the hard work. This is 40, so x is 40 degrees. Okay? I don't know where you guys ever seen the three angles of a triangle must add to 180. Boom, that's 2, by the way. But you really need to make sure you guys are comfortable and cool with the fact that the three angles of a triangle add to 180. Boom, that's 3. I know it's a double hit, but it's all good. Alright, moving on to the back. Okay. Properties of congruent triangles. Alright, RST, 1, 2, 3. You guys have seen these words before. I'm bringing them up again for you guys, but reflexive property of congruent triangles. Every triangle is congruent to itself. So I can say that triangle ABC is congruent to triangle ABC. I know that sounds really silly. I totally agree with you. It is very important, that property, in terms of proof. I will not touch on proofs that much. I will show you 1 or 2 examples. But reflexive properties, like looking in the mirror, seeing yourself. Okay. Symmetric property. It's symmetric. Alright, sorry. If I'm taking a look at this, if triangle ABC is congruent to triangle DEF, I can say then triangle DEF is congruent to triangle ABC. Alright. Symmetric property means you can flip it around, it will still work. Good. My last part, transitive property of congruent triangles. This is my personal favorite. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, you see how they're both congruent to the same triangle? Therefore, these two must be congruent to each other. Triangle ABC is congruent to triangle JKL. Right? Now, you heard me say in the beginning of this RST 1, 2, 3, R, 1 congruent sign. S, 2 congruent signs. T, 3, 1, 2, 3. Alright, that's the way I remember it. Again, like I told you guys, I'm terrible with memorizing. That will help. Okay? Number 4. Find the value of x. Alright, this is a throwback to yesterday. Exterior angle theorem. I put this on here because it will be on your test, so I want you to be comfortable with it. And that's an awful exterior, but my bad. You can take the two inside things and add them together. 63 plus x. And set it equal to your outside thing, 7x minus 3. Alright, I want to solve this. I can distribute. So the 63 plus x on the left-hand side stays the same. On the right, 7x minus 21. I want all my x's on one side. Subtract x, subtract x. Okay, cool. I want that minus 21 over. Think about the opposite. Plus 21, plus 21. 6x then equals 84. Divide by 6. X equals 14. Okay. If they would ask you to find the measure of the exterior angle, what you could then do is take this 14, plug it back in over here, 7 parentheses 14 minus 3, 7, think about order of operations, do this first, 7 times 11 is 77 degrees. Okay? And that makes sense because if I did put 14 back in up here, 14 and 63 gives me 77, I know I rock. Okay. Find the value of x. Now, this is the third angles theorem. Third angles theorem. One arc, one arc. Two arc, two arc. That means the last ones have to be equal. Alright? So I can make up an equation here. 5 parentheses 3x plus 5. That'll equal 55. Alright? I want to distribute that 5 across. Okay, 15x plus 25 equals 55. Solve, I can subtract 25 from both sides. 15x equals 30. Divide by 15. X equals 2. And if I had a few extra minutes in my time, I could come over here and go 5. 3 times 2 plus 5. 5, 6 plus 5. 55 degrees. I know I'm good. All's well. Alright. Triangle ABC. ABC. D is 1, 2, 3. Congruent to DEF. Alright. What do I know about the three angles of a triangle? F to 180. Boom. 4. Okay. I'm going to just stick it out there. It didn't really pertain to this problem at this exact moment. But if I'm looking here, okay, I want to solve for x and for y. X is on the outside. FD. FD is the first and third. The first and third over here is AC. Boom. So 3x equals 9. Alright. Divide. X equals 3. Cool. Now, you kind of can tell where we're going with this, but D is for my y, which is the first spot. The first spot over here is A. So again, I can make up an equation. Okay. Add 3 over. 5y equals 25. Divide y equals 5. Okay. So feel free to grab classwork, try that out. Okay. And that about wraps up congruence triangles. And what are three angles of a triangle have to 180? Boom! 5. I thought you were thinking I wasn't going to do it, but oh, sneak attack. Whoa. Alright, sorry, that's my own little fun. Anyway, keep up the good work, and as always, good luck. We are all counting on you.